This is the video for the Unit 13 of Solving Polynomials for our final exam in the spring of 2018 in Algebra 2. So we're going to start with number 38 here. If we look at it, it says, what are the zeros? Another word for zeros is x-intercept. So we want to know, where does this cross the x-axis if we're looking at a graph? Or what solutions are there? There's a bunch of different words that we've used. If we look at our function, that has three terms, meaning we're going to use split the middle. We're going to split the middle on that. So to split the middle, we multiply the 1 and the negative 36 together. So that's negative 36. And we need all the factors of 36. Okay, and then we'd have to choose which one to make negative. If we look at 9 and 4, 9 and 4 could get us to 5 if we to add, so we would do 9 minus 4 would get us a positive 5. So we're going to break up those middle terms. We keep the first term, and then we have plus 9x squared. And it's x squared because that original middle term was an x squared, and we're splitting it into two terms. So, and then minus 4x squared. So that total, 9x squared minus 4x squared, gets us the 5x squared. And we have minus 36 at the end. So you'll notice my middle term split, and then my outside term stayed the same. And from here, we do grouping. So we pull out an x squared from the first two terms, and that would leave us with x squared plus 9 on the inside. And then in our second two terms, we can pull out a negative 4, and that would get us an x squared plus 9. And your whole goal on this step is to make sure that your parentheses are the same. Once they are the same, then you're good to go. And the parentheses will be one of your answers, the x squared plus 9. The other two answers come from the x squared minus 4. So there is the factored form of our answer. But we actually want to solve this because it says what are the zeros or the roots. It doesn't ask for the factored form. So if we take this x squared, oops, can't go over there. If we take this x squared plus 9 and we set that equal to 0, and we solve it, we would subtract 9, take the square root to get rid of that square, and so we would have plus or minus the square root of negative 9. Well, we know that when we have a negative inside the radical, we bring out I, and then radical 9 becomes 3. You can write it as plus or minus I3. Typically, we like to say it 3i, so we write 3i for our final answer on that one. So that is two of our answers. And then my x squared minus 4, let me write that. My x squared minus 4, that is a difference of squares problem. Because 4 is a perfect square, there's technically a 1 in front of this x squared. So we can take the square root of both of those, and we have that subtraction inside, which means we for sure know it's difference of squares. So square root of x squared is x. And the square root of 4 is 2. One of them will be positive, and one of them will be negative. So my answer here, I get x equals negative 2. Here I get x equals positive 2. We can write that as plus or minus 2. So those are our four answers, plus or minus 3i, and plus or minus 2. And we know that we should have 4 roots because the original function was a degree of 4. All right, moving on to 39. 39, I'm going to go ahead and rewrite that problem so that we have some room here. It has 4 terms. Now we learned when we did factoring at the beginning of the year, when you have 4 terms, try grouping first. So we're going to go ahead and we're going to group this guy. So the first two, we can pull out an x squared. And so that would leave us with a 2x minus 1 on the inside. And then, let's see, on the right-hand side, we need to get 2x minus 1, meaning we need to pull out a negative there so we can flip our signs. And we can also pull out a 9 because a 9 is common between 18 and 9. So the 2x minus 1 is one part of our factored form, and then the x squared minus 9 creates the other part of our factored form. But it's not fully factored because, again, we have difference of squares right here. X squared minus 9, we can break that up. So if we take the square root of x, square root of x squared, we get x. The square root of 9, we get 3. One of them is positive and one of them is negative. And we keep that 2x minus 1. But again, we don't want factored form. We're trying to find the roots, which is basically the same thing as 38. Roots, zeros, solutions, x-intercepts. They all mean the exact same thing. So we're going to set that first parenthesis 2x minus 1 equal to 0. And we're going to add 1 to both sides. And we're going to divide by 2. So we get x equals 1/2. So that is one of our answers. And then here, we know we just flip the signs on these. X equals 3 for that one. X equals -3 for that one. And since the original problem was a cubic, a degree of 3, we know we should have 3 solutions. All right, now question 40. Determine the solutions of the polynomial x cubed minus 64. So for this one, we need that difference of cubes formula, which I've provided here on the slide. So we're going to go ahead and fill in our a and our b once we figure out what they are. So a is in front of the x cubed, and b is the cube root of 64, which is 4. So if you're not sure what that is, you can go into your calculator and hit the cube root, which you would have to choose math in the top left-hand corner, and then go down to where it has the cube root, and you could choose 64 in there, and it would tell you 4. And then obviously cube root of 1 is just 1. Even if we did the square root, it would be 1. So our a and our b are 1 and 4. We're going to plug them into our formula over here. So we have ax minus b, so 1x minus 4. You don't have to write the 1 on that. And then ax squared, or 1x squared, plus abx, so 1 times 4, which is just 4x, and then plus b squared. 4 squared is 16. So here, if we take our x minus 4, that gives us the solution of x equals positive 4. And then we have to do either split the middle or quadratic formula here. So quadratic formula or split the middle. You can try split the middle on these. I would go straight to quadratic formula. If we look at this, if we try to do split the middle with 16, okay, our options for multiplying to 16 are 8 and 2 and 4 and 4. Neither of those options will ever add to 4, so we know that we need to do quadratic formula. All right, so quadratic formula, I'm going to go ahead and put that on here for us. All right, so if we pick out our a, b, and c, a is in front of x squared, so in this case a is 1, b is 4, and c is 16. So we're going to go ahead and fill those into our quadratic formula. And remember, when you're doing the quadratic formula, it's all over. The square root is not the only thing that's over 2 times a. The whole thing is over 2a. All right. So we're going to go ahead and get the part that's under the square root first. So if we do 4 squared, 16 minus, we should get -48. And so when we get a negative under a radical, we have to make sure we pull out an I. So we're going to go ahead and take out I. And we can see, is there a perfect square that goes into 48? And there's actually a couple that we could try. If you try 4, 4 is not the biggest one that goes in. So I would keep trying your perfect squares. 16 times 3 is 48, and 16 is the biggest perfect square that will go into 48. So then from here, we just break down the square root of 16 is 4, so we write that as 4i, radical 3 over 2. And then from here, it's just breaking down right here. We can simplify, which is -2. And here we can also simplify. 4 over 2 is positive 2 there. Yes, we technically have plus or minus. So there is our other two answers. So if we go back up, negative 2 plus or minus 2i radical 3 would be our other answer. So those are our two answers. Well, technically three answers because the second one has two answers in it for number 40. All right. 41 and 42 tell you that you can choose long division or synthetic for both of them. It doesn't really matter which one you do. I'm going to show you both here. So since 41 is already set up in long division form, I'm going to go ahead and do long division on number 41. So to do long division, we start with the first terms of the outside and the inside. So we take 10x to the fourth and we divide it by 2x, which is outside. And that gets us 5x cubed left. So that 5x cubed is what goes on the very top. And then we multiply. 5x cubed times 2x is 10x to the fourth. And then 5x cubed times negative 3 is negative 15x cubed. Okay, but keep in mind this is a subtraction problem. Whenever you do these, you're doing subtraction. So our 10x to the fourth will cancel out. And that should always happen. Our first term should always cancel out. And then if we look at this next one, it's negative 13 minus a negative 15. Right here, this is like addition now. So we get a positive 2x cubed. And we bring down the rest of the terms. And that's really one cycle of long division. So from here, we do the exact same thing over again. We take our front number, 2x cubed, front term I should say, divided by our front term of 2x for our divisor. And here, we're left with an x squared. So that's the next part that goes on top. And then we multiply again. X squared times 2x is 2x cubed, and x squared times negative 3, negative 3x squared. But we're doing subtraction. So our first terms will cancel out. And then we have negative 7 plus 3 is negative 4x squared. And then we bring down the rest. Okay, so now we've done two full cycles. We're on cycle 3. So we're going to take that front term, negative 4x squared, divide it by the 2x. And that leaves us with negative 2x. So again, that goes on top. And then we multiply. Negative 2x times 2x, negative 4x squared. And then 2x times negative 3, I'm sorry, negative 2x times negative 3 is positive 6x. Keep in mind it's subtraction. So right here, this will become addition, and those cancel. And then we have 8x minus a 6x, which is 2x. Bring down our plus 4. All right, one cycle left. So we have 2x divided by 2x, which is 1. So I took my 2x here, divided it by my 2x that I've been dividing by, and I got what? So 1 is our last number that will go at the top. And then we multiply that. 1 times 2x is 2x. 1 times negative 3 is negative 3. Keep in mind we're doing subtraction. 2x will cancel. And then 4 minus the negative 3 is like 4 plus 3, which is 7. And 7 is our remainder on this one. So to write your final answer, first of all, we know that this is not a factor, okay? So 2x minus 3, our divisor, okay, is not a factor. And that's because we got a remainder of 7. If we would have got a remainder of 0, we know it's a factor. But because we got a remainder other than 0, it's not a factor. So we write our final answer by taking the quotient at the top. So 5x cubed plus x squared minus 2x plus 1. So we take that, and then we add our remainder over the divisor to show our final solution. All right, for this one, for 42, I'm going to go ahead and do synthetic division on this one. Keep in mind here to check your terms. So we have an x to the fourth and x cubed. We're missing an x squared right there, okay, where I put that blue mark. So we have to make sure we add that term in. So we're going to take our x plus 2, and when we write that as a solution, that's x equals negative 2. So when we do our box for synthetic division, it's going to be negative 2. Remember, you flip that sign when you put that in the box for synthetic division. And then we bring down our coefficient from our polynomial. So we have 3, 6, and then I told you we're missing that x squared. Make sure you put in 0 as your space filler for that x squared. And then we have negative 2 in front of our x to the first, and then we have 4 as our last number, our constant. All right, so first step, bring down your 3, drop that 3, multiply 3 times negative 2, which is in our box, and we get negative 6, and we add down. We do the same process over again. 0 times negative 2 is 0, add down. Put my addition sign here, make sure you're adding. 0 times negative 2 is 0, add down. Negative 2 times negative 2 is positive 4, add down. Now, when we get to the very end, this is kind of similar to long division, where if we get a 0 here, okay, we know it's a factor, but because we got 8, that means x plus 2 is not a factor. So we're going to go ahead and write our solution the same exact way that we wrote the other solution. It's a little different in finding it this time. So we started with an x to the fourth function. That means we are now down to an x cubed function. So when we write this, it'll be 3x cubed plus 0x squared plus 0x minus 2. Now, we don't need all of those zeros in there. So we can simplify that to be 3x squared minus 2. And then we have to add our remainder at the very end over the divisor. And that's your final solution. Okay, we have one problem left, I believe, and this is where you have to find all of the roots in the solutions, real and complex, so some of them might have I in them, of the following polynomial functions, and it says show all work. So we're not told what to use here. Typically, if we go back, right, with synthetic and long division, we had a divisor. This time we don't. So we have to go to our graphing calculator. So you're going to go to your graphing calculator, and you're going to put in 2x to the fourth minus 13x cubed, all of that into y equals, and we press graph in the top right hand corner. And we look and we see what are two of our roots. Well, here we have 5. This one, not quite sure. It looks like it might be 1.5, but we need to trace it to make sure. So to trace it, you press second, trace, and number 2, 0, because that's another word for solution or x-intercept. And so we do our left bound, so I gotta find my cursor here. There it is. Okay, so left bound, go down below it to the right bound, and then our guess will be right on it. So yep, it is 1.5, which is good news. So we know that 2 of the roots that we can check with synthetic division are 1.5 and 5. So let's go back to our notes here. We know that we have x equals 5 and x equals 1.5. So we're going to go ahead and use synthetic division with those. We're going to check 5 first. We just did synthetic division here in the previous question, if you watched that one. So we're going to drop down our coefficients. And we're not missing any. 4, 3, 2. Yep, we're not missing any on this one. Okay, so the first step is drop that 2. And then we multiply 2 times 5 to get 10. And we add down. Remember, it's addition. multiply 5 and negative 3 to get negative 15. And we will add down, so that's 5, it's 8. 5 times 8 is 40. If we add down, we get negative 12 on that one. And then negative 12 times 5 is negative 60. So we have to get a 0 there. The issue with these problems is if you don't get a 0, that means you either didn't have the right root originally, or you didn't do something right with synthetic division, because we just saw this. If we go back to our calculator, we know for a 100% fact that 5 is a root. So we should get 0 as our remainder. If we don't, something silly happened. So we need to check our work. All right, now that we've done synthetic division with 5, let's go ahead and do synthetic division with 1.5. And we're going to keep narrowing things down here until we can find the rest of our roots. So remember, when you do this, you don't use the original coefficients. You use the coefficients that you just got with your last synthetic division. So we're going to drop those right down. Okay, and we're doing synthetic division again. So we're going to drop our 2. 2 times 1.5 is 3. And add down. 0 times 1.5 is 0. And add down. 8 times 1.5 is 12. And it should be. So we get 0 at the very end. Again, if you don't get 0 as your remainder, something silly happened, because we know for a fact we just saw it on the graph. So we started with an x to the 4th. This would be an x cubed function. And that means this one is an x squared function. So if you take those new coefficients, we would have 2x squared plus 0x plus 8. So I'm going to rewrite that over here without my 0. I don't need that 0. Ooh. All right, now to get the rest of our roots, we can just solve this. We're going to subtract 8 from both sides. Something silly's happening with the board. Let's try to move up top here. All right, so subtract 8. Not quite. All right, we'll try to go to the bottom. All right. Take 3. So we subtract 8, divide by 2, x squared equals negative 4. We know to get rid of that square, we need to square root both sides. Don't forget your plus or minus. And when we take the square root of 4, we get 2. And don't forget I because of that negative under your radical. So those are our other 2 roots. So we know that we started with x equals 5 and x equals 1.5 as well. So 1.5 and 5 were our original roots. And then we also found 2 complex roots of plus and minus 2i.